next talk is about generic binding, improving bind with C++ 11 and 14 features, and it's done by Christoph Wanzke from TV Group, and they are doing traffic planning software.
Have you noticed that it's already 3 weeks until Christmas? And this year Santa Claus came up with the idea to optimize his present tour at Christmas night, doing some cool optimizations with C++ 11 and 14. So let's dive directly into his really hard code, into his really complicated code. And his main function is this one, simulating and optimizing the visit of each children in the world. So in this function, as you can see, expects basically 2 parameters. One parameter is a reference to the list of all good children in the world, and the other parameter is an ID of a child visited in this function. And you can assume that in the function body of this function, there are made decisions based on if the child ID is member of this list of the good children. So let's assume that's not all, of course, that's just one function. So there are, of course, data structures. There are, of course, a list of all the children in the world, and there is a list of the good children in the world. And of course, as you might expect, the bad children, the odd children are the difference of both of these sets. So this is the one point. Then there's a simulation around this function. There is an iteration around this, and therefore we use standard for each. And you know, of course, standard for each expects a begin and end of a set, for example, or a list, for example, and it expects a callable operator. It expects a function or a lambda or etc. And in this case here, we can use standard bind for it. So we use standard bind, and we bind to the original function visit child, the original list, the reference to the list of the good children, and, well, there's the standard placeholder left. We have here to specify and define, yes, there is a left parameter of this function, but we do not know it yet because it will be handed in the function, in the iteration of standard for each. But hey, come on. We are living in a world, in a time of auto-type deduction, of lambdas, of cool stuff in C++ 11 and 14. So wouldn't it be great to have a generic bind function doing it for us? So give it to the compiler, that the compiler will determine, well, yes, there are remaining unbound parameters during this bind procession, and yes, the compiler is able to get it. So it would be great to have a generic bind getting just the function pointer to our visit child and the set or the list of all our good children Santa Claus is visiting at Christmas night. And I'm going to show you how to implement this generic bind function from the scratch. Let's start. So generic bind is just a function, and we are going to fill in the 3 dots at each point here. So let's consider first, what does generic bind expect? So as we can assume, well, of course, it expects the function we want to bind. It expects the function visit child in our case, for example, and it expects, well, some parameters left, and therefore we have the great opportunity in C++ 11 to use variadic templates. So variadic templates are exactly what we want here. Variadic templates tell us, well, we know there will be some parameters of arbitrary amount, of arbitrary type, but currently we do not want to care about it. We say, well, let it the compiler do. We don't want to care about it at this point. And of course, here are not some magic types. Of course, this is an entire template function using a function type and using the variadic template parameters here. So, and that's even all this function expects. Okay, let's go further. Let's just jump into the function body. What do we want to have within this function body? Well, of course, we want to return a callable object, and even with C++ 11, there are lambdas, and so we return a lambda here. And we return a lambda, and this lambda captures, of course, the pointer or the original calling object. It captures visit child. And it captures all those parameters entered here in the parameter list of generic bind. Those are the 2 captures of this function. Okay, let's go further. Let's consider what does this lambda expect as parameters? And here we have a new great cool capability of C++ 14. Here we can also use variadic lambdas introduced with C++ 14, and we do not even also have to care about which concrete explicit parameters do we expect here. Now we can say, well, let it the compiler do and go further at this point. So I will show you in a moment how those parameters will be determined within the function body. So that's the point. So we return a lambda capturing the function pointer and capturing the bound parameters passed to generic bind as the parameter, as the variadic parameter para. Okay, let's go into the lambda now here. So this lambda actually calls the function fun. It calls, when the lambda is called, the original function or the function pointer fun is called, and it gets two, or at least variadic parameters again. So here we just have to write two variadic parameter blocks, but of course there are several parameters due or specified by the original function list of the original function. So let's assume our list, our function, our original function with a child had two parameters, and we first bind the list of the good children, then para is the list of the good children, and x is the unbound parameter, originally being standard placeholder 1. So, and the compiler now is so clever, he can't see, or the compiler knows, well, I know all expected parameters of our original function, and he knows, yes, cool, the programmer gave me some specific bound parameters para, and then he is so clever to get the difference of all parameters and the bound parameters. And now there are 3 dots left. Let's fill them in. That's pretty easy. It's auto. So since we do not know the original type of the lambda, and it depends on the implementation of the compilers, and there's some cryptic stuff, so we can just use auto here and let it the compiler do again. So we can just say, well, I do not care about the actual return type, let's just write auto. And of course, we are C++ programmers, we care about performance. So there might be several functions having references, L value or R value references. So let's add some perfect forwarding to the entire stuff, and I can tell you that's it. This is all you need to implement the generic binding handed into the standard for each. So let's see another example. So let's assume in our Santa simulation, he wanted to fly with a sleigh, and the sleigh expects 3 explicit reindeers, A, B, C, and of course, we instantiate some reindeers. Let's call them Donner, Blitzen, and Rudolph. And now we are going to bind those reindeers to the sleigh. So using generic bind. So we define a new function, a new callable object, fly with 1 reindeer, and call therefore generic bind with the original method fly sleigh and bind the first reindeer to it. Okay, and we can continue with it. Since fly with 1 is a callable object, we can bind again now to the new callable object fly with 1. We generate with generic bind, binding to fly with 1, the next reindeer, a new callable object fly with 2. That's great, and now let's call it. So now we call it, and well, there's of course 1 reindeer left. So, and this is the point where auto comes into account, the auto lambda. Here we can just pass another reindeer to the remaining left parameter, which is the left parameter C, which is missing here, and this is of course Rudolph. So I like that. This is pretty cool, and I very like that. But we are talking about C++, and in C++ there are always possibilities to shoot yourself horribly into your foot. So, and the same problem occurs here. For example, when you try to bind R value references, you call generic bind with standard move, and then you change the original object. Then it can be that when you call the generated function with generic bind, there is no reindeers, for example, inside, because we just bind an R value reference. And binding an R value reference does not mean to call the move constructor or the move assignment operator. So here you can shoot yourself horribly into your foot. So be careful with doing stuff like that, and have a great Christmas time. Merry Christmas.
Questions?
So can you please show the implementation of this generic bind again?
Yeah.
I mean, you already mentioned that it could have potential problems with values that are, basically bound to the function.
This one?
Yeah, okay, so first doesn't it create a dangling reference if one of the parameters is a temporary?
Beg your pardon? Sorry?
I'm not sure, doesn't it create a dangling reference if one of the parameters is actually a temporary value?
Yes, that's what I said.
Yes,
But when you work with R-value references here, it might be that there's some dangling pointer.
Yeah,
or
so you need basically some small wrapper around these things which basically aggregates all temporaries and stuff.
Yes.
And the second thing is that you then step forward, but I think you mentioned that one, if you then step forward the captured parameters, that you also risk of moving the stuff out, and which may be problematic if you use this binding object twice. But yeah, I think I mean you can probably know how to fix it. Can be done, but okay.
So as I said, the problem is that the function body of the lambda is not called directly when you bind it, when you generate it. It will be called when you execute the returned callable object, when you execute this lambda. And what happens in between, well, nobody knows. Or you should definitely care about it and be careful.